Good morning, guys. I will explain again how to take into account the values for A, for B, and for C in a quadratic equation in order to solve the worksheet you have in Google Classroom. Okay. The idea is we're going to again explore different options in which we can, by changing the values for A, B, and C, we can see the curve. Again, a quadratic equation has this form. 8x squared plus bx plus c. In the worksheet, you will have to change values for A, for B, and for C in order to see what is happening with the curve. Okay. First, we're going to explore changing the values for A, changing values for A, okay? In this case, I'm going to take only the part of x squared, okay? I'm going to ignore or bx plus c. I will not take into consideration this part of the expression, only ax squared, okay? First, when you change the value for a, for example, we are going to say that a is equal to 1. We will have that the expression is 1x squared. In this sense, we can see this kind of graph, okay? We can see this kind of graph where the value for a is equal to 1. Now, what happens when the value of a is different to 1? For example, a equal 3. We can find that the same curve is going to be closer to the y-axis, okay? In this sense, for example, we are going to explore Desmos. I'm going to explore Desmos. Yeah. Let me open a new sheet, okay? In this one, for example, when we have the value 1x squared, we have this. And when we have the value 3x squared, we have this. If you see the blue curve, when you are changing the value for a and the value is greater than 1, we are going to see that the curve is closer to the y-axis. We see the notability that is happening with the value of a, okay, the value of a. But what happens when the value of a, for example, is equal to a negative number, for example, -2? We can see that the curve is going to be wider. That means, for example, in Desmos, we're going to write minus 2x squared. Yeah, sorry, minus 2x squared. Actually, we are changing the side where the curve was drawing. In this sense, is this one is equal to is this one, okay? But that happens when you have different values for a. Only for a. Don't consider b and c, okay? Now, what happens when we have values for b? For example, x squared plus bx, but we don't consider the value c, okay? In this sense, I'm going to do an example. For example, I'm going to take the same 1x squared plus 1x, okay? If we see this graph, we're going to see that the curve, based on this new value for b, their curve is moving from 4 is moving for the x-axis, okay? That means when you are changing the value for b, you are moving the graph over the x-axis. And doing the example in Desmos, for example, if you take a value, for example, 1x squared plus 1x, that is the value for b, if you see, we are moving the curve a little to your left. That means when the value for b is positive, the curve moves to your left. In case of negative number for b, is going to be contrary. It's going to move to your right. Okay. Doing a different example, taking different value for b, 1x squared plus 5x, for example. If you see, we are moving more to the left side. That means to the negative side. Okay, that is the consequence of changing the value for b. Now we already know what happened when we change the value for a and now the value for b. Now finally, we need to know what is happening when we change the value for c. In that sense, we are going to take 1x squared plus 1x plus a number c that can be any number, for example 5. If you see, we have a component, that means a, that is going to make this kind of graph or this kind of graph or this kind of graph. We have the component b, that is when we are moving, through the x-axis. And now the component c, if the b make us move to the x-axis, the component c make us move to the y-axis. In this sense, for c, for example, we will have the following: that we are moving 5 points up, and we will have this kind of expression where the y-intercept, in this case, the point you have in the y, that is the minimum point, is going to be equal to the component c. Okay, doing this in Desmos, for example, we will have 1x squared plus 1 for bx plus 5. If you see, the curve move up 5 places. Okay, by doing a different example, changing the value for c, for example, we are going to say we have, for example, minus 5. If you see, we're moving through the y-axis to the -4 down, because the c is negative. Okay, with this information you will have enough to complete the worksheet. Okay, now we are going to explore some simple concepts in quadratic. For example, when you have this kind of curve, is curve up. When you have this kind of curve, is curve down. It's curve down when the component a is negative, and curve up when the component a is positive. Okay, guys, I think so with this information you will have enough to solve the worksheet. Even you have an extra video in which I explain all about quadratic. All that we have done so far is there. Have a nice day, guys.